We're looking at specification point 1.1.5, size and mass of atoms. So we've already looked at the relative charge of protons, neutrons and electrons. Now you're looking at the relative mass. So protons have a relative mass of 1. Neutrons have a relative mass of 1. But we can state that the relative mass of an electron is very small. An approximation is 1 over 2,000 the mass of a proton or a neutron, 1 over 2,000. What we're going to consider now is something that will probably blow your mind. We're going to look at the radius of an atom and the radius of the nucleus of an atom. Now, these are far too small to be able to see, and we've now developed microscopes that can look at them. And these are the numbers you need to remember. The radius of an atom is about 0.1 nanometers. So if you were to write that in standard form, it'd be 1 times 10 to the power minus 10 meters. The radius of the nucleus of an atom is 1/10,000th that of the size of the atom. So the nucleus is a 10,000th the size of the radius of an atom. So that means 9,999 parts of an atom are actually empty space, the distance between the nucleus and the outside of the atom. That blows my mind. If you were to write the radius of the nucleus of an atom in standard form, it'd be 1 times 10 to the power minus 14 meters in size. Now, when we consider the mass of an atom, what we're doing is we're considering the mass of the protons and the neutrons, because the electrons have such a small mass. So the mass number of an atom is the sum of the protons and the neutrons in that atom. Now, I mentioned it before, but we'll mention it again. There are some atoms that have the same number of protons, but a different number of neutrons, and they are isotopes. So isotopes are atoms of the same element with a different number of neutrons, or different neutron number. Before you go on here, make sure you know what the size of a radius of an atom is. Make sure you know the size of the radius of the nucleus of an atom. And make sure you know the ratio between the size of the atom and the size of the nucleus. Make sure you understand that the mass number is made up of protons and neutrons, and the isotopes have the same number of protons but a different number of neutrons.